Hello guys, I'm Varun, and today I'll be speaking on the topic of classful addressing. I'll cover three classes mainly: class A, B, C, and I'll just mention a bit about the class D and E. So let's begin. First of all, I'd like to talk about what is an IP address. So an IP address is an address having information about how to reach specific hosts, especially outside the LAN. An IP address is of 32 bits. So like you can see right here, these are 8 bits, these are 8 bits, these are 8 bits, and these are 8 bits. So this makes a total of 32 bits. So the space given to this will be 2 raised to 32, which is quite large. And generally, there are two notations in which IP address is written in dotted decimal form and hexadecimal notation. So, like this one, this is the dotted decimal form, as you can see, and this is the hexadecimal form. So, for hexadecimal, as you can see, I just divided it into groups of four and then just converted it into the hexadecimal equivalent. So some points to be noted about the decimal notation is that the value can range from each of these octets can range from 0 to 255, and both are included. 0 and 255 both are included, and there are no zeros preceding any number, like it cannot be 011 or 053. These are invalid. Only 53, 11 and such numbers will work. So let's move on. So the 32-bit IP address is divided into subclasses. There are 5 subclasses: class A, B, C, D, and E. So these two are reserved for research and experimental purposes. This is reserved for multicast purposes, and this is reserved for experimental purposes. And these three are currently in use. So an IP4 is divided into a network ID and a host ID. So we'll see what those are. See, like in this diagram we can see the basic structure of all the class A, B, C, D and E addressing, classful addressing. So like you can see that the total IP address is of 32 bits, out of which certain bits, like in this one, first 8 in this, first 16 in this, first 24, and these are just reserved. So like you can see, according to the bits reserved for the network and the host, we have divided it into subclasses. So we'll move on to the A subclass first. So like you can see that the total number of possible IPs is 2 raised to 31. Also you can see, like I showed in the previous slide, like this was the basic structure. So the first bit of the 8-bit reserved for the network ID, this is for the network ID. These first 8 bits, and the next 24 bits out of the 32 bits are reserved for the host ID. So as you can see that the first bit in the 8 bits is reserved and is always 0. So the values that can range will be from 0 to 127. Why? Since like if you put it like this, there's 1 1 second. Yeah, so like this is the 8-bit form, 4 and 4. So this will be equivalent to 127. Okay, so like this can range from this 0 included and this. So the total number of possible networks will be 2 raised to 7. That is, since this one is fixed, this bit is fixed, so 2 raised to 7 minus 2. Now you'll ask, where did we put this minus 2? So let me tell you that in any network, like suppose we take 125.0.0.0, and we'll go on till 125.0.0.255. I mean, this 255.255. So this network ID and this network ID, these both are reserved. This is for the network itself, network, and this is for the broadcast group. This is for broadcasting. And what does broadcasting mean? Let me clear the ink. So suppose that we have a network and it's got multiple connected pieces inside nodes. Like suppose this is the network A. So if we want to send a message to all of these nodes at the same time, so we'll use the broadcast ID. So that's used for internal broadcast. The last IP, internal broadcast. So like as example was not 255.255.250. This is used for broadcasting to everything. Like it will send us the same message to every single node. Okay. So you can see the number of hosts. As you can see, this is our 2 raised to 24, and the first and the last are reserved for the network and the broadcast, as I told you before. So it will be approximately 16 million possible hosts in a class A network. So we'll move on to B. As you can see in the B network, let me change the color. So in the B network, the first two bits are reserved, and instead of the 8 bits, we have got 16 bits reserved for the network ID, and the next 16 bits for the host ID. So you can see that 2 are reserved. So the total number of possible networks will be 2 raised to 14, as we discussed earlier, and the total number of hosts will be 2 raised to 16 minus 2, since these are reserved for the broadcast and the network ID. And the range of this particular one is 120 to 191. So this includes approximately 64, and the previous one included 128 possible networks. This includes this this many number of possible numbers. So moving on to the C class, like you can see that we have increased it again by 8, so it will be 24 bit for the network and 8 bit for the host. So the first three are reserved, hence we have got to restore 21, that's 21 bits left for the number of networks. For the host we have got to restore 8 minus 2, same logic, that broadcast, and the network ID itself. Okay, and in this we have got approximately 32. The range of this one is 32. So these are the three IDs that are most commonly used. As you can see that the number of hosts in each network varies by a lot, like this is 65,000, this is 16 million, and this is only 254. So as you can see that the flexibility in this thing is quite low. As if a company, suppose a company wants 1000 IPs, so we cannot provide class C. Why? Because it's only got 254 hosts. Like it wants address for 1000 hosts or IPs, you can say, to run a system of 1000 hosts. So it's too less. And if we provide this, the rest of the 64,000, approximately 64,000 hosts will go to a waste addresses. So this is not quite flexible. So moving on to the D and E, like you can see in the D, all the bits are reserved for the host. Like this is used for multicasting. As I told you earlier, this particular D class is used for the multicasting, and this is used for experimental and military purposes. Okay, so yeah, that's it. So the range for these both is 16 each. Like this is from 224 to 239, this from 240 till 255. That's the last one. So yeah, one more thing, that all of these contain a subnet mask. So the base subnet ID for class A is 255.0.0. For this is 255.255.0.0. For this one 255.255.255.0. So yeah, that was the basic of class A, B, C, D, and E. So what are the disadvantages? As I told you, that this is not quite flexible. Like flexibility means that you can adjust it according to your needs. So like you can see the problem with class, millions of class A addresses are wasted, like I told you. Like if we only want 10,000 addresses and we provide the class B, still approximately 50 to 60,000 addresses are wasted. And like same case, these are wasted. In this, it's so small that we cannot provide. Like there are only 254 possible addresses in the class C, so we cannot provide this. And class D and E are reserved for the military and other purposes, multicast routing and experimental purposes. So these addresses are wasted. That's a lot too. So yeah, for this we had introduced classless addressing in 1993. We won't be covering that in this lecture, but yeah, for solving this problem, we took the approach of classless addressing. So yeah, that was the video. Thank you for watching.